I hope that some of you tried to do this on your own and you were able to do it. If not, don't worry, we'll do it together in this video. We will create a custom function that we can reuse for other purposes in the app. But to begin, I want to create a new file in my project. It will be a Swift file, which I will call utils. And in this new file, I can then begin by defining our function, which we can then use globally in our application. I will call my function random bool with a parameter odds of type integer. Our function will return a bool value, which we can then, for example, use to decide whether we want a grass or a road lane. Inside of the function, I will create a constant called random, which will be set to arg for random uniform, and for the upper bound, I will specify a uint32 with the upper bound odds. I can then use an if statement to check if random is less than 1, in which case I will return true, else I will return false. What this means is that if I, for example, pass 3 as the argument to this function, our arg for random uniform call will give us 0, 1, or 2 for the random constant. This means that the probability of random being less than 1 is about 33%. And that's pretty much exactly what we want to use in our game view controller inside of the for loop. So let's jump back and skip to our for loop, where we set the type constant. Instead of just using the static value grass, I'll now call my random bool function with the odds 3, and can then use the ternary operator to assign a different value to type, depending on whether or not this returns true. If it does return true, I will say lane type.grass. And if not, I will say lane type.road. This means the probability of a road lane is about twice as high, so about 66%. Let's run the app again and see if we have some road lanes already in our map. We can clearly see that we now also have lanes with our asphalt texture, and they also seem to be spawning more frequently than our grass lane. All of this still looks pretty two-dimensional as of now. And we can't even see that our road lanes are actually lower than our grass lanes, which we explicitly created with a higher geometry. So let's take care of this now. I'll stop the app, and the easiest way to achieve this would be to actually take a second look at our camera. And then instead of having it face straight down, we want to tilt it slightly so that the game perspective becomes more three-dimensional. If we only move our camera, this will allow us to still calculate our movements later in the game fairly easy, because we can still, for example, to move right, just move by 1 on the x-axis, and we don't have to account for any transformations of our map. All we're really changing is the perspective of our camera and how it faces our map. Since we've already created our utils file, I want to go back to it now and implement a little helper, so we don't have to calculate our radiance values for the angles manually each time like we did here, but maybe have a more convenient method that does this for us. At the top of our utils file, I will define 2 constants. The first will be degrees per radians, and it will be set to the float value of double.pi divided by 180. And a second constant, radians per degrees, which will be the float value of 180 divided by double.pi. And we can then use these constants to create functions for CG and float that can then easily convert angle and radian values. I'll begin with a function called toRadians with a parameter angle of type float. And a return value of type float. Inside of the function, I will just return angle times degrees per radians. I will then create my second function, which will also be called toRadiance with a parameter called angle, this time of type CGFloat, which will return a CGFloat value, and inside of this method I will return angle times the CGFloat value of degrees per radians. I have to cast this explicitly as a CGFloat here so that the multiplication works. I also have the error that the type CGFloat is undeclared, but this can easily be fixed by importing SceneKit in our file. We can now use these functions to easily convert angles to the appropriate radians values, and we'll do it right away back in our GameView controller in the setup camera method, where we as of now have defined our negative 90 degrees as negative.pi divided by 2. Instead, I can now just write negative to radians and plus 90 for the angle parameter, which will automatically calculate the radians value for me. I do want to change this from 90, which would be straight down to a little less of an angle, so maybe 72. I will now also define a rotation for y by calling toRadiance with the angle 9, which will turn our camera slightly to the side. That's all we need to change. The position of the camera can stay the way it is, and the rest of the scene doesn't need any adjustment neither, since we are basically just fixing our perspective. I can now run the app again and see if the angle of our camera is different. Perfect. This seems to have worked, since our lanes are now a bit more diagonal than they were before, which already looks a lot more like the look that we're going for with our Crossy Road game. We can also see that the little gap at the bottom is gone, and all we see is our map with the lanes. What's still invisible though is the height difference between our grass and road lanes, which I said should make our scene look more three-dimensional. To change this, we'll have to add lights to our scene. As of now, there are none, and just some default lighting. We will now add two different light sources. One that is ambient and lights every element of our scene, and one directional light that will allow us to cast shadows and really make our elements appear more three-dimensional. And this is what we're going to look at next.